and what you guys can expect. So we have 3 class periods left plus the assessment day, which I think is Friday of next week. So we're gonna, in those 3 days, we're gonna start chapter 5, and we'll have a homework quiz for chapter 5 somewhere in there. The last homework check for those assignments is going to happen Tuesday at 8 a.m. instead of Sunday at midnight. Since you guys have 1 class day next week also, it didn't make a lot of sense to me to have like 2 homework checks for you, but 1 homework check for the A class, the class on the A day. So we're going to do that way this time. So preparing for a little with the grades here at the end, I've already dropped the low homework quiz score, but nothing really happened for you guys because I also entered into the grade book this last homework quiz and marked it as a missing. So everybody's drop is being applied to this missing last homework quiz that we haven't taken yet. So as soon as we take that and that grade goes in, the drop will move automatically to whatever your real lowest is. I also am going to drop a low assignment score, which again didn't do anything for you guys because this last homework check I've already put in the grade book and marked as missing. When that goes, when you do that assignment and turn it in, the drop will get moved to wherever your other lowest one is. And then I've doubled your high test scores. So basically I made a new test category and just put in your best test grade again another time. So you can take that and you don't have to tell me that you don't want to do that or whatever. Like I'm doing that automatically for everybody for free, unless you'd rather retake an old test. So if you'd rather forego the doubled high test score and instead retake an old test, I will allow you to do that on the assessment day. That's Friday of next week, with the caveat that the max score you can get on your retake is the lowest of your other test scores, or 75%, whichever is higher. Basically, the retake is going to be advantageous for the person that got like A's and B's on all of their tests except one that they got like a 50 on. So you can think about that over the next couple of days about what you'd like to do. If you want to do the retake, you should email me by 8 a.m. on Friday if that's something you want to do. But basically what it comes down to is if you look in the grade book right now, unless you elect to do the retake and do bad, like worse than you did before, which I'd find hard to believe considering you have the option to do it, your grade is not going to get any worse than it is right now. So if you do the other homework quiz and you do the other assignment, it'll improve a little bit from those, but it can't get any worse than it is right now. Any questions about kind of the grades or the end of the semester there?
Mr. Kulik?
Mm-hmm. Yes. Uh-oh, he froze. That's funny.
Mr. Kulik?
Yeah, Amy.
So then, for assessment day, are we like going to take a test on chapter 5 or no?
No. The only people that'll be taking a test on the assessment day are the people that want to do a retake. Everyone else will just kind of come in and we'll take some attendance and then leave shortly thereafter, unless you're doing one of the retakes. I should mention here, when you email me about the retake, you need to include what chapter test you want to be retaking, right? If you're somebody that's wanting to do that, got to let me know, is this chapter 1, 2, 3, or 4, so that I can make a retake for you. Other questions about this? Okie dokie. That seems pretty straightforward then. So today, we're going to be talking about, or start talking about polynomials. So we're going to start talking about polynomials here in this semester, and we'll kind of review a little bit and finish this topic in second semester. So the topics that I want to talk about here is adding and subtracting, multiplication and division, synthetic substitution, factoring, and solving. Now, these two topics, factoring and solving, are quite rich topics. We're not going to do like the whole treatment of factoring and solving. We're just going to do the areas there in factoring and solving that are related to quadratic factoring and solving, that are should be a relatively easy extension from the things we've already been working on. There's a lot of other factoring and solving techniques that we'll deal with in second semester that are unrelated, or at least have a lot of parts that are unrelated to the factoring and solving. We did it with quadratics, so it's kind of a different approach and a more general approach that really demands a lot more time than I have available in 3 class periods. So we won't get to that this semester, but surely we'll come back and look at it in second semester. Okay. So today, my plan is to look at these 3 topics. We'll come back and do a little bit more division tomorrow also, but I'm going to look at these 3 topics today. So let's just say that I have, a couple of polynomials. And we'll use these to do some examples. So if I want to add these 2 polynomials, the way we write that is we say f plus g of x. And really the nice thing about polynomials is that the sum of this polynomial is just, we can find that by just adding its 2 component polynomials together. We can just add f and g directly. And since we're adding these, there's really no reason that I need parentheses to separate the F and G, right? So I can just drop those parentheses and just combine the like terms. So I have 3x cubed and a negative 3x cubed. That's going to give me 0. Well, I'm not going to bother to write the 0, but... And then I have negative 7 and positive 8. Those are like terms. Those combine to or add to give me 1. And then I have these other leftover pieces that don't have a, oops. I don't know what I did there. That's supposed to be a 4 here, guys. Doesn't make a lot of sense to have a polynomial with 2x cubed terms in it. Why wouldn't we have combined those like terms in the first place? I don't know. Made a mistake. And usually when we write a polynomial, we write it in standard form, where I write it from the exponents in descending order. And we did this basically already at the start of the previous chapter when we talked about quadratics, right? We did a little bit of adding and subtracting of polynomials there. So, same idea if I'm going to subtract f and g. I can just subtract those two component polynomials. But here I can't just drop the parentheses all willy-nilly. The first parenthesis has nothing in front of it, so I can drop that one. But the second parenthesis has this negative sign, so I need to make sure that I'm distributing that negative sign through before I drop that parenthesis. Now that I've done that, I can just combine like terms just like I did before. So I have a 3x cubed and another 3x cubed. Remember, when we add monomials like this, we add their coefficients. So 3 plus 3 is 6, but their exponent stays the same. And then 7 or negative 7 and negative give me negative 15. And then these guys don't have like terms to pair with, so they just will stay the same. And then typically we write this in standard form, where we start with the biggest degree exponent and work down to the smallest degree exponent. Again, this was something that we kind of did already in the beginning of chapter 4, so that should look pretty familiar. Next up is multiplication. Which again, it's nice. We can just worry about multiplying like the two component part polynomials. So one way that we can do this multiplication is I can just multiply each term in the first polynomial to each term in the second polynomial. So that would mean I would multiply like this, and then like this, and then like this. And that's now like a lot of stuff to kind of keep a track of. So we'd have what? We have 12 things that we'd have to multiply out and then keep track of and then recombine. And it's going to be a little bit of a endeavor to do that. What I find easier from an organizational standpoint is this method. So what I'm going to do is I'm going to draw like a grid here. And across one side of the grid, I'm going to write one polynomial. It doesn't matter which one. Since I drew this one a little bit longer, I'm going to put the longer polynomial there. And you'll notice when I wrote this one, I wrote this 0x squared term. If I look at this polynomial, you'll notice I go from x cubes to x to the firsts. And I don't have an x squared. It's going to make my life a little bit easier to include that squared term in my grid here that I'm going to draw. So I'm going to do that. Similarly now, on the vertical, I'm going to write my other polynomial. And again, you'll notice that I put a 0x there because, again, I was missing the x term. I went from squared to constant in my other polynomial. And now I'm just going to kind of draw in some grid lines. So each of these boxes here represents a multiplication problem. For example, this first box is going to be the product of 3x cubed and 4x to the fourth. So when we multiply monomials, we multiply their coefficients. So 4 times 3 is 12. And we add their exponents. 4 plus 3 is 7. So now I'm just going to kind of continue this process, filling in these boxes. So I'm not going to say what goes in each of them, because if you're doing this too, it certainly gets pretty confusing when you're writing numbers and somebody's saying a different number potentially. So we'll pause here for a second, let everybody catch up. That's still copying things, but just keep in mind that this is not any difficult table to have replicated. While you're copying, I want to point out a couple of nice patterns or nice features of this table. If we look at the exponents, as we look down our table from top to bottom, notice the exponents decrease by 1. So for example, in the first column, we go from 7 to 6 to 5 to 4. In the second column, we go from 6 to 5 to 4 to 3. And that pattern continues throughout the entire table. That's the advantage of putting the zeros in. Additionally, if we look from left to right across the table, that pattern also holds. So the exponents go 7, 6, 5, 4, 3. In the next row, we go 6, 5, 4, 3, 2. So that's very nice. But the best feature of this is that if we look along the diagonals, so the diagonals of this grid have all of our like terms together. You have all the x to the 7ths, all the x to the 6ths, all the x to the 5ths, and so on. All of our like terms are all lined up and very easy to find, and that we had kind of discussed, where you're just kind of left to kind of find them on your own. So to get our final answer from this table, we're just going to combine our like terms now. So 8x to the 6th and negative 9x to the 6th is negative 1x to the 6th. 0, negative 6, and 0 is negative 6x to the 5th. And negative 28, 0, 0, and positive 12 is negative 16x to the 4th. 21, 0, 8, and 23 is 53x to the 3rd. 0, 0, and 16 is 16x squared. Negative 28 and 0 is negative 28. And negative 56. And while I admit that this grid method takes up a little bit of space, it's quite simple, right? All the multiplication problems are really easy. And it's nice because it sorts all the like terms for us together, so it's really easy to find the like terms. And adding like terms is not a problem. So just keep that in mind. You don't have to use this, but I think it's a really useful and clever organizational system that we can use to kind of keep track of what could be a very overwhelming problem, because there's a lot of kind of things to keep track of. Next up is division. But before we talk about polynomial division, I want to go back and talk about good old long division that you guys would have done in elementary or middle school. I don't know, like 5th, 6th, 7th grade, somewhere like that. So let's say we wanted to do 5,381 divided by 26. So we start by writing the divisor, that's the second number, out bar, and underneath the division bar we write the dividend, that's the name we give to that first number. And then what we did was we go by digit. So we ask, okay, how many times does 26 go into 5? Well, the answer there is 0. So we move on and say, how many times does 26 go into 53? Well, 2 times 26 is 52. And then we subtract down. So 5 minus 5 is 0. 3 minus 2 is 1, and then we'll bring down the next digit. And we repeat and ask ourselves, how many times does 26 go into 18? Well, the answer there is 0. So go bring down our next digit and ask ourselves, how many times does 26 go into 181? Well, the answer there is 5. So 5 times 26 is, no, it's more than that. Mr. Kulik, you're so silly. 6 is 20 and 120 and 36. That's 56. Or 156. And then, so I think it's 7. Nope, that's 1 too many. It's got to be 6. All right, so we have 156. Subtract down. Gets me 7 carry the 1. That's 5. 25. Remainder 25. So we'd say that 5,381 divided by 26 is equal to 206. We call that number the quotient, plus our remainder, that's the 25, over the divisor, which is, again, 26. Hopefully you remember kind of doing this process before in your elementary or middle school classes. We're going to basically be using the same procedure, but applying it now to polynomials. So there's a couple of differences between polynomial long division and regular long division, but in a way I think it's actually a little bit easier. So let's say we have 5x cubed minus 2x squared plus 7x minus 10 divided by x plus 2. So we'll set this up the same way we did for regular old long division. The divisor goes on the outside, and the dividend goes underneath. Now, one way that this process differs from long division is that all we care about are the leading terms. So my first question is going to ask, how many times does x go into x cubed? Well, I know that 5x squared times x gives me 5x cubed. So I'm going to just multiply the 5x squared to the entire divisor, write it underneath, and subtract down. Now, one of the places where I see the most mistakes made by students is forgetting to distribute the negative sign. So let's do that right now. So the negative of a positive is negative. Negative of positive is negative. So I just distributed that negative sign and got rid of the parenthesis there. So we have 5x cubed minus 5x cubed is 0. And I have negative 2x squared minus 10x squared is negative 12x squared. And then we'll bring down the next term. And now repeat. So we're going to ask ourselves, how many times does x go into negative 12x squared? Well, that's easy. That's negative 12 times x gives me negative 12x squared. Now I'll multiply that negative 12x to both pieces of the divisor. Negative 12x times x gives me negative 12x squared, and negative 12x times 2 gives me negative 24x. Then we'll subtract down. Once again, I'm going to distribute my negative sign through. So negative of a negative becomes positive. Negative of a negative becomes positive. And I can drop my parentheses there. So negative 12x squared plus 12x squared is 0. 7x plus 24x is 31x. And then we'll bring the negative 10 down. And then we'll go back to the top and ask ourselves, how many times does x give us 31x? Or how many times does x go into 31x? Well, that's easy. It's just 31 times. So I multiply that. I'm sorry, I couldn't really hear what you said there. Was somebody trying to ask a question? No? Okay. If you change your mind, let me know. 31 times 2 is 62. And then we'll subtract down. And again, we'll distribute through our negative. So negative of a negative is positive, and negative of a positive is, negative of a positive is negative, and negative of a positive is negative. So 31 minus 31x is 0. Negative 10 minus negative 62 is negative 72. So that's my remainder. So the answer to this problem is my quotient, 5x squared, minus 12x plus 31, plus my remainder, negative 72, over my divisor, x plus 2. Okay, let's do another example, because again, while this process should look relatively familiar, because it's basically the same idea as as long division, it is complicated enough that it's probably worth doing more than one example here. So let's say we're going to do 10x to the fourth minus 8x cubed plus 7x minus 10 divided by x squared plus x minus 3. We'll start the same way. We're going to write the divisor on the outside of our bar, and our dividend is going to write underneath. Now, you'll notice here that in our dividend, we go from x cubes to x to the firsts. Just like when we did the multiplication, I'm going to include a 0 x squared term. And you're really going to want to make sure you do that here, because it's going to make the problem considerably easier to deal with, because we'll make sure that like terms are all going to line up by doing that. So you've got to make sure you remember to put in those missing terms. It doesn't matter where they're missing, whether it's in the divisor or the dividend. It doesn't matter how many are missing. You want to include all of them wherever they're at. Okay, so we'll begin by asking ourselves, how many times does x squared go into 10x to the fourth? Well, I know 10x squared times x squared gives me 10x to the fourth. So I'll multiply that to each term of my divisor. And then we'll subtract down. Just like I did before, I'm going to distribute that negative sign through. So negative of a positive is negative. Negative of a positive is negative. And negative of a negative is positive. So 10x to the fourth minus 10x to the fourth is 0. Negative 8x cubed minus 10x cubed is negative 18x cubed. 0x squared plus 30x squared is 30x squared. Then I'll bring down that next term. And I'll go back to the top and ask myself, how many times does x squared go into negative 18x cubed? Well, the answer to that is negative 18x, because negative 18x times x gives me negative 18x cubed. And then I'll multiply that to all the terms of the divisor. Negative 18x cubed minus 18x squared plus 36x. And then subtract down. And just like before, I'm going to distribute my negative. So negative of a negative is positive. Negative of a negative is positive. And negative of a positive is negative. So negative 18x cubed plus 18x cubed is 0. 30x squared plus 18x squared is 48x squared. And 7x minus 36x is negative 29x. And I'll bring that last term down and go back to the top. So I'll ask myself, how many times does x squared go into 48x squared? Well, 48. So I'll multiply that to each term of the divisor. Gives me 48x squared plus 48x minus 144. And then we'll subtract down. Just like I've done each time, now I'll distribute my negative. So negative of a positive is negative. Negative of a positive is negative. Negative of a negative is positive. 48x squared minus 48x squared is 0. Negative 29x minus 40x is negative 77x. And negative 10 plus 144 is 134. So that's my remainder, because I have nothing left in. So the way I'll write my final answer, we'll say that this division problem is equal to 10x squared minus 18x plus 48 plus my remainder, which is negative 77, 134, all over the divisor, which is x squared plus x minus 3. Okie dokie. Next up, we're going to talk about synthetic substitution. But before we do that, let's just talk about substitution in general. So let's say we have the polynomial f of x equals negative 4x cubed minus 7x squared plus 10x minus 6. And we're interested in what f of negative 2 is. What f of negative 2 means is that we're just going to plug a negative 2 in for x and then evaluate. So here we have 32, squared, minus 28, minus 20, minus 6. So we have negative 30 then. Oops. Not negative 30, negative 22. Okay. So if we did the same thing with synthetic substitution, is going to be just a different process that's going to accomplish the same goal. So let's just say that we have that same polynomial. And we're still interested in f of negative 2. So we're doing the same problem, we're just using a different technique. This different technique is called synthetic substitution. So the way we set this up is we draw like this little L bracket. And on the outside of our L bracket, we're going to write the number that we're plugging in. And then inside of our L bracket, we're going to write down the coefficients in our polynomial that we're plugging that number into. Just the coefficients too, no variables. So that's what the setup looks like. The first step, we're just going to bring that first number down and write it underneath the bottom of our bracket there. Let's write these in, the results in black. That's the first step. Now what we're going to do is we're going to multiply the number on the outside to that number underneath and write the answer in the next spot and add down. So negative 2 times negative 4 is 8. Negative 7 plus 8 is 1. Now we're just going to keep repeating that same process till we filled up all the spaces. So negative 2 times 1, and then add down. Negative 2 times 1 is negative 2. 10 plus negative 2 is 8. And then once more, negative 2 times 8 is negative 16. Negative 6 plus negative 16 is negative 22. That's our answer, just like we got before. And right now you're probably thinking, why in the world would I ever want to do this method when regular substitution that you showed me the first time appears so simple? And you're right. We wouldn't really use this method to do substitution. The nice part about this method is that it also scales, and we can use it to do a variety of other things that are much more complicated than substitution. So these numbers here at the bottom can be interpreted another way. We'll talk about that more tomorrow, but we can use this technique to do things other than just substitution. But this is kind of the entry level for learning this process, is to just use it to do substitution. But it's a more powerful technique than that, because we can do things more than just substitution by doing this. But we'll talk about that more tomorrow. Let's do one more example of this, since it is brand new, I would suspect, for everybody. Yeah, let's make it a 3. Okay. So we're going to substitute 3 into the polynomial. Negative 4x to the 4th plus 3x to the 3rd minus 2x squared plus 3. And then the coefficients on our polynomial, we write inside of the L bracket. Notice here, though, that we go from x squareds to constant terms, and we don't have x's. Very critically important that I include the 0 there. You will get your answers wrong if you don't include the zeros, so make sure you're being very careful about that. So there's my setup. Okay. So my first step, bring down the first number. Then we're going to do the outside times the bottom, write it in the next spot. 3 times negative 4 is negative 12. 3 plus negative 12 is negative 9. Three times negative 9 is negative 27. Negative 2 plus negative 27 is negative 29. Oops. Three times negative 29 is negative 87. 0 plus negative 87 is negative 87. And then 3 times negative 87 is 240 plus 21, so negative 261. And 3 plus negative 261 is negative 258. And it's just this last number that we care about right now. Okay. This is as much as I want to do today. So your assignment is going to be this homework 1 that you can find in the content library. So I give you 3 polynomials here, f, g, and h. And for number 1, I just want you to just do a little bit of vocab review from the last chapter. List the degree, the number of terms, leading term, leading coefficient, and constant term for each of the polynomials. Then I have an addition, a subtraction, and multiplication problem, 3 synthetic substitution problems, and then 3 polynomial long division problems.